All right, guys, so let's talk about how to run a simple ANOVA. So I am using wire BSS data, and let's say we want to look at grade level and cigarette smoking. Now for this data set, I have gone in and removed any blanks for grade as well as the number 5, which corresponded to ungraded. So we're just looking at numbers 1 to 4, which is 9th to 12th grade. So if we want to examine if there's a difference between 9th graders, 10th graders, 11th and 12th graders, and how many are smoking cigarettes, we want to run an ANOVA. Now, if you remember from my repeated measures ANOVA tutorial, a repeated measures ANOVA is for within subjects, and a regular ANOVA is for between subjects. Now, we know wire BSS data is between subjects data because each of these rows corresponds to a different person. We're not measuring data over time, so we're going to run a regular ANOVA. So let's go to ANOVA, click just regular ANOVA, and we are going to put Q3, which is grade, in our fixed factors box because that is our independent variable. And our dependent variable, which is cigarette smoking, is going to be Q32, and that's going to go in our dependent variable box. We are ignoring WLS weights. So now we have this output, and so we look at our p-value, and our p-value is less than our alpha of 0.05, which is telling us that within these 4 grades, there is a significant difference between the means of those 4 grades when it comes to smoking cigarettes. So let's look at where those differences are, and we're going to do that by running a post hoc test. So let's go here, post hoc tests, and we're going to move Q3 from the box on the left to the box on the right. 2 key is automatically checked. That is typically what we want to use. Sometimes JASP does not want to run 2 key and instead will automatically check Bonferroni. That is fine, but for this test we're using 2 key. Now let's look at our post hoc, and what we see is we have each of our grades over here. So 1 is 9th grade, 2 10th, 3 11th, 4 12th. And it is comparing the means of cigarette smoking between these grades. So let's look at 9th grade compared to 10th grade. And let's look at our p-value, P2 key. It is 0.051. That is greater than our alpha, so that's telling us that although we can see from a t-value that there is a difference, it is not statistically significant, okay? But if we look at 1 and 3, which is 9th and 10th grade, we have significance, and that is the same for every other grade compared, okay? So 10th grade and 11th, 10th and 12th, 11th and 12th. These are all statistically significant. So there are significant differences in the means of cigarette smoking between these grades, okay? So let's see what that looks like by plotting this data. So we go to descriptive plots. We're going to move Q3 to horizontal axis, and we're going to get this output. And so what this is showing us is that, okay, we see there is an increase in cigarette smoking from grade 9 to grade 10, but it's not a lot. And we know from these numbers up here, it is not statistically significant. So although we can see there was an increase, it was not a significant increase. But if you look from grade 10 to 11, there is an increase, and it is statistically significant. The same goes from 11th grade to 12th grade. So what this is telling us is that as far as cigarette smoking, 9th graders and 10th graders, not a huge difference there. We know that 10th graders smoke a little bit more than 9th graders, but not by a significant amount, but that 11th graders smoke significantly more than 10th graders and 9th graders, and 12th graders smoke significantly more than all other grades, okay? So that is how you do a very simple ANOVA analysis, and remember this is between subjects, and that is why we used an ANOVA as opposed to a repeated measures ANOVA. Thank you all for watching, and I will see you in the next video.